Hey guys, and welcome to the NFT 101 tutorial. My name's Jonathan, and I'll be your instructor for today. I'm really excited because today we are going to go through the entire process of creating an NFT collection, deploying it to the Ethereum blockchain, and listing it for sale on the OpenSea NFT marketplace. So if you wanted to learn how to create your own NFTs but didn't know where to start or exactly what the process is, you've come to the right place. We're going to cover everything step by step so that you know exactly how to create NFTs, deploy them to the blockchain, and start selling them on the internet. I think you'll be surprised at how easy it is, and you don't even actually need to have any programming experience in order to get this done. So if that sounds good, stick around and let's get started. Alright, so before we get started, let's just go over some NFT basics. NFT stands for non-fungible token. A non-fungible asset is something that is unique in nature and can't be replaced or traded for anything else for equal value. On the other hand, a fungible asset is something that can be traded for something else of equal value, like a dollar or a Bitcoin. For example, if I have a $100 bill and you have a $100 bill, we can trade and we'll both end up with $100, the same value that we started with. If we trade NFTs, however, there's no guarantee that we'll end up with the same value as before due to their unique nature. Examples of NFTs range from digital art like CryptoPunks or Ether Bears to items or wearables in games or in metaverse platforms such as Decentraland or Sandbox. Many other applications of NFTs are just beginning to be explored, and the potential use cases seem limitless at this early stage. Alright, so before we get started, let's take a look at a quick roadmap for this tutorial. First, we'll be setting up our workspace using Hardhat, which is a development environment for Ethereum. Next, we'll be creating our ERC-721 NFT smart contract using the OpenZeppelin library. More on that later. After that, we'll create our NFT metadata and upload the NFT image and metadata to IPFS, which is a distributed peer-to-peer network, using an application called Pinata. Then, we'll deploy our NFT smart contract to the Ethereum testnet and mint our first NFT. Finally, we'll view our newly minted NFT on OpenSea and look at how we can use the OpenSea UI to easily create a collection for our NFTs and list them for sale. Alright, there's just one more point I want to cover before we get started, and that is that the focus of this tutorial isn't really on creating NFT art itself. It's more on the technical process of how to create the smart contract, deploy it, and then how to list your NFTs for sale. So, for the purpose of this tutorial, we're going to be using some NFTs that I've created, some sample NFTs called CryptoBeetles. They're basically pixelated beetles or bugs. And I'll add a link in the description of where you can download a couple of these NFT images. So please feel free to download them, copy them, use them however you want. And you're also free to use your own NFT artwork if you have it available and name your project accordingly. All right, so let's get started in creating our development environment. Okay, so as I mentioned earlier, we're going to be using Hardhat, which is an Ethereum development environment, to create our project, and basically it provides some code out of the box to help us with deployment and testing. So I just wanted to quickly show you the Hardhat website here, hardhat.org, and you can always feel free to refer to the documentation over here under the documentation link. But we'll be going through all of the setup steps, step by step, so hopefully you won't need to refer to this page, but just in case you need to, just know that it's here. Alright, so I'm going to flip over to the file system, and I'm just going to find a place where I want to create my project here. So the first step, I am going to open up Git Bash, or feel free to open up any terminal of your choice. And let's go ahead and make a new project directory. So I'm going to do make directory, and I'm going to call this one NFT smart contract. Okay. So now I'm going to switch into that directory. And the first thing I'm going to do is create a new npm project. So I'll do npm init. And I'm just going to quickly step through all of the options, just using the defaults for everything. Okay, great. Now the next step is going to be to install the hard hat library. So I'm going to do npm I for install, save dev, hard hat. And I'll pause the video while that is installing. All right, hard hat is now installed. So the next thing we want to do is create a new hard hat project. So I'm going to do a npm x hard hat. And you're actually going to see that this is going to fail. I've run into this a couple of times before. And basically, if you read the error messaging down here, it says to use PowerShell if you're on Windows. So yeah, it doesn't work, unfortunately, in GitHub, in Git Bash. So I'm going to go ahead and open my code editor, which I'm using Visual Studio Code. And I'm just going to open the terminal and rerun that command. Okay. So again, make sure that you're in the right directory. And do npx hard hat. All right, so give it a little while. This may take a few minutes. Well, that was pretty quick. Okay, let's create a sample project. Yes, yes. And it looks like it's finished, but it's suggesting that we install some other dependencies here. So I'm going to go ahead and do that. And basically, this is for testing, and the ethers library is for interacting with the smart contract from our scripts or possibly from the UI. So I'm going to go ahead and follow that suggestion to get that installed there. This will take a few minutes, so again, I'm going to pause the video. All right, so now that that's installed, let's go ahead and take a look at the files and sort of the folder structure that Hard Hat's installed for us. So we've got a contracts folder, and inside there we have a sample greeter contract. All right, we're not going to use this, so you can ignore that for now. We've got a scripts folder with a sample script, and we're going to reconfigure this to be our deployment script. So we'll get to that in a minute. We've got a test folder, and then we've got our hardhat.config file. So this is a really important file in that we can use this file to point to whatever network we're targeting for our deployment. So let's go ahead and set that up now. Make sure as the first line you have a require for the Hard Hat waffle framework. And there's no need to explicitly require ethers because waffle depends on ethers, so it's implicitly brought in there. And then we've got a sample task here. We can ignore that for now. All right, so one thing we're going to want to do is update the Solidity version to match the version we'll be using to code our smart contract, which at the time of recording this video is 0.8.11. So you can update that right here in the module.exports. And then the next thing we'll do is configure our hard hat to point to the Rinkeby Ethereum test network. So what we can do is go right below the Solidity version here and define a networks object. Give it some curly braces. There we go. All right, so this will take two properties, or will contain two properties. The first one being a URL. And we'll just leave the empty quotes for now. And then we'll need the private key for the account, the wallet account that we're using to deploy our contract. So let's just set this up. We'll give it a empty array. This takes an array. And now we'll need to go out and figure out how to get these two bits of information. Okay, so for the network URL endpoint, we're going to be using something called Infura. And I'm going to open my browser here. And I'm going to go to infura.io. Now, Infura is basically a set of APIs that allows us to connect to the Ethereum blockchain in an easy way. So what you're going to want to do is come here and sign up for a new account. Now you can get a free account just for the purposes of this tutorial, and it'll probably be good enough to for a couple of small projects. You can see it'll allow you to work with 3 projects, 100,000 requests a day. So plenty to get started here. So if you guys want to just set up a free account, just come over here to sign up and go through the motions here. And when you can pause the video and come back here when you're done. Since I've already signed up, I'm just going to go ahead and log in. So once you've created your account, well, I need to go back here to the first page. Log in. Yeah, go ahead and log in. And you'll be redirected to your dashboard. So what you can do is create a new project and just give it a, well, select Ethereum. It's an Ethereum project, and give it a name. You can call it NFT tutorial, or if you have a specific name in mind for your project, you can call it that. Go ahead and click on the create button. And I'm not going to do that since I've already got a couple of projects set up here. But you should be redirected to your project dashboard, or you can navigate to it by /dashboard once you've set up a project. Then I'm going to go ahead and reuse one of my existing projects for this tutorial. So go ahead and click on your newly created project, and then what we're going to want to do is go to project settings. And here's where we can grab that URL endpoint information. So down here under keys, we're going to want to go ahead and in this dropdown select the Rinkeby test network, and we want to copy and paste the first URL here, the HTTPS URL, to our clipboard. Now let's go back over to Visual Code, and we'll copy and paste that into the URL field for now. All right, so the next thing we'll do is set up our MetaMask wallet. Now pretty much everything done on the blockchain is address-based, and so we'll need to set up that wallet. MetaMask, if you're not familiar with it, it's a really easy setup. It's just a browser extension for Chrome. So I'm going to go ahead and open my Chrome browser, and I'm just going to do a quick search for MetaMask. And it should be the first search result. Go ahead and download now. Install MetaMask for your browser. Go ahead and click on the install button. Okay, I'm going to click on add to Chrome. Add extension. Just have to go through the motions here. It'll just take a second to get added to Chrome. Okay, and there's our confirmation. And what I'm going to do is pin this to make sure I can just easily access this at all times. So there we go, pin MetaMask. I'm going to go ahead and click on Get Started. And so we want the second option here, create a new wallet. Okay, scroll down, go ahead and agree to the terms, and go ahead and create a new password for your wallet. Okay, and again, agree to the terms, and oops, I've done something wrong here. Try that again, there we go. And go ahead and click on Create. Okay, so MetaMask is now creating a new wallet for us, and it's going to give you some information about securing your wallet. Just click Next, and I'll explain what they're saying here. Go ahead and click on this box where it says click to reveal secret words. Now, this is your secret recovery phrase or secret passphrase. And basically, these are the keys to your wallet. So it's very important that you never share this, never deploy it online anywhere to GitHub. Keep it in a very secure spot. Now, I'm going to be deleting this account as soon as this tutorial is over. So in this case, it's okay for me to share this with the world on YouTube here. So what I'm going to do is just, for now, you can copy this to a notepad. Okay, let's go back over to MetaMask, and we can click the next button once you've saved that. Now it's going to ask you to confirm your secret recovery phrase. So what you've got to do is select the words in the correct order here. So I'm going to try to do that really quick here. Okay, and I wish I could memorize it all at one go, but multitasking here. Purity, dolphin, flush, crack. Okay, and the last four. Okay, so once you've chosen your words in the correct order, go ahead and click on Confirm. Congratulations, and click on All Done. And you can just X out of this box right here. So it's going to go ahead and open up your wallet in the browser. I don't really like to see the full screen version of it, so I'm just going to open it right here from the extension bar. And there we go, it opens up in a nice pop-up. All right, so as you can see, we've got one account to work with. Here's the account number right underneath there, and a 0 Ether balance since we're first just starting off here. Now what we can do is we can grab the private key for this wallet by clicking on the little 3 dots here and scroll or go down to account details and export private key. Okay, and it'll give you the warning. Of course, you never want to share this with anybody. I'm going to enter in my password and go ahead and click on confirm. All right, so now just click in here to copy, and we can go ahead and paste this back in Visual Code. Now, I'll tell you what, I'm just going to paste it here in quotes for now. What we're going to do, because it's not really a good idea to have your passwords and endpoints and things like that hard-coded, so we're going to set up a .env file and read it from there. So let's go ahead and install .env. I'll go back to my terminal and do npm i.env. Now once that's completed the install, we're going to want to go ahead and import it at the top of our hardhat config file. So I'm going to do require .env and .config, just like that. Okay, don't forget to save your file. Now let's go back and we'll create a new file in the root of our project called .env. All right, now inside this file, let's make 2 variables. We'll do one for, let's see, so the first one will be Rinkeby endpoint, or we'll just say URL, okay? And the next one will be private key. Okay, so let's go ahead and go back to our config file and grab those values. So I'm just going to kind of grab them both here at the same time to make it a bit easier. Paste those down here. All right, so I'll grab the URL first. No quotes needed, so just grab it and directly paste it there. And we'll grab our private key and paste that right here. All right, excellent. So let's go back to our config file, and now we can reference these values just like this. So we'll do process.env dot Rinkeby underscore URL. And for the accounts, again, this needs to be an array. So it'll be an array of one value. And we'll say process.env dot private underscore key. Okay, great. Now, there's one more thing. We just want to make sure that our .env file is specified in our git ignore. And there it is right there on line 2. So just absolutely make sure that you have this. It's really important that you not publish your private keys or your secret passphrase anywhere on the internet, or somebody can basically have access to your entire wallet. All right. So with that, our config is set up, and we're going to start on creating our new contract. So I'm going to go into the contracts folder. I'm going to create a new file. And as I mentioned before, I'm going to be using these CryptoBeetle NFTs, these sample NFTs that I created. So I'm going to name my contract CryptoBeetles.sol for solidity, but feel free to name this file whatever you want, whatever your project's going to be, or feel free to use this example. All right, so in order to create our CryptoBeetles NFT smart contract, it's actually going to require very little coding, and that's because we are going to largely fall back on the OpenZeppelin NFT ERC-721 standard smart contract. So let's go take a look at that for a minute. I'm just going to search for OpenZeppelin. So OpenZeppelin, it's an open source project that just provides a lot of boilerplate and contract code that typically is sort of the gold standard, as it says here, the standard for secure blockchain applications. Now this code is widely used in ERC-20 tokens, which are tokens created on top of the Ethereum blockchain, and also for ERC-721, which is sort of the golden standard for NFTs. So let's take a look at this. I'm going to go to Products, Contracts, Docs, and I'm going to go down here under Tokens to ERC-721. So we'll be creating an ERC-721 smart contract for our NFT, and we're going to copy and paste this code here and just make a few slight modifications to work for our purposes. All right, and we'll go through it line by line. However, the base code here is the ERC-721 smart contract. So this contract example is inheriting from ERC-721, which means it has access to all of the code in that file. And if you want to dig deeper into what that looks like, you can come down here under API, ERC-721, just to see sort of what the core functionality of an NFT looks like. And so if you go down to functions, here's the implementation standard for 721. And the purpose of the contract, the 721 smart contract, is basically to keep track of who owns which NFTs that have been minted from that contract. This is the balance of. You can look at balance of by the owner address, or you can check the owner of a specific NFT. And it also has functions and methods to facilitate sales and transfers and things like that. Okay. So let's go back to tokens ERC-721. And what we're going to do is copy and paste this code into our editor and then make our changes. So I'm going to go ahead and grab this whole thing. I'm going to go back over to Visual Code, and I'm just going to go ahead and paste that into our CryptoBeetles.sol. All right, let's go to the top here. You can see the first comment here references the name of the contract, so you can update that if you want to. Okay, I'm going to update our Solidity version to 11 to match what we specified in the hard hat config. So you see a couple of imports here, all from the OpenZeppelin library, and this is showing as red because we haven't installed that yet. We'll do that in a second. So the ERC-721 we just sort of briefly went over. That is your core NFT functionality. Now we have some additions which are optional that we've added here. ERC-721 URI storage. That just provides some functionality for retrieving the URL that points to the metadata and the NFT image. And then we're importing a little counter utility here, which just gives us an easy way to increment our token IDs. So you could write this functionality yourself if you wanted to, but this just provides an easy and consistent way to do it. All right, so let's open up our terminal and actually install this library. So I'm going to say npm I at OpenZeppelin/contracts. So this is going to download all of the OpenZeppelin contracts and install it into our node modules folder in our project. So hopefully these little warning messages will go away as soon as that's installed. That'll just take a minute or so, so I'll go ahead and pause the video. All right, so that install is complete. I'm still seeing some squiggly warning lines here, but I'm not going to worry about that for now because I know that these packages are installed. By the way, if you're working in Visual Code and you don't have the Solidity extension installed, I highly recommend that you get that installed just because it'll give you some syntax highlighting and things like that. You could just search for it here. I would just search for Solidity, and it's usually the first one by Juan Blanco. So definitely suggest you install that. It just makes it a lot easier to work with Solidity code. All right, so let's just make a couple of changes here. The first thing to do is change the name of the contract. And I usually like to have it match whatever the file name is. So I'm going to say CryptoBeetles, and feel free to name it whatever your project is. Then the next thing I'm going to do, instead of hard coding, so basically this is how we inherit in Solidity. we're importing these libraries up here from OpenZeppelin, and then we say contract CryptoBeetles is ERC-721. There's a comma separated list here, and then ERC-721 URI storage. So that's how we specify that we're inheriting from these other contracts here. And so in the constructor, which is basically the function in our smart contract that is a place for us to put some initialization code, we can call the smart contract of we can call the constructor of the smart contracts that we're inheriting from. So in this case, the ERC-721 takes the name of the contract and the the ticker symbol. So what we want to do, we want to actually specify this at the deployment time. So we'll make some changes here. We'll modify our constructor so that it takes a name and symbol argument. So I'll say string memory underscore name. And the memory is just a data storage specification saying that this is basically in-memory storage that just lasts for the lifetime of the function. We'll say string, again memory, and symbol. Okay, now we can reference those here in the ERC-721 constructor with underscore name and underscore symbol. Okay, great. So once we get to writing our deployment script, we'll pass in these values. This just makes it a little bit more flexible, a little bit more dynamic. Now, this sample smart contract that we copy and pasted from OpenZeppelin is basically for an in-game sort of NFT reward. But in our case, we're just creating a very basic digital art NFT. So we don't need some of that functionality here for the game. And if you see here, this function called award item, this is a basic wrapper for the minting functionality, and they're minting the NFT to the player. So in our case, we're not going to mint an NFT to anybody. We want to mint it to ourselves so that we can then decide what to do with it. Send it to somebody or put it up on OpenSea for sale, etc. So we can get rid of that first argument, and then down in the mint function call, we'll just remove the reference to player, and we'll put message.sender. Okay, and that'll just be the address of the deployer of this contract. In other words, our address. All right, and I think we should also change the name of this function since it's not really accurate anymore. So I'm just going to say mint, all right, because we're literally minting a new NFT to ourselves, and that's it. It's pretty basic. All right, let's take a look here, make sure everything is okay. And I think those are all the changes we need to make. So with that, we're done coding our smart contract. And the reason why we did this, I didn't discuss this earlier, but why are we using the OpenZeppelin contract instead of writing our own from scratch? Well, this code has been tried and tested thousands of times. It's widely used in the industry. I would say, over 90% of NFTs are using some variation of this code from OpenZeppelin. It's just the industry gold standard, and why reinvent the wheel? So why take a risk writing new code from scratch when we know this code works? We know it's solid and sort of tried and tested. So that's sort of my reasoning behind that. All right, so let's move on to the next step. We are good here. All right, guys, so the next step in our project is going to be to deal with the NFT metadata, which consists of 1, the NFT image, and 2, a JSON file which describes the NFT. All right, so there's a link in the description of the video to the images if you want to use my test images. And I'm just going to go ahead and, well, I'll tell you what, in the code editor, let's first create some infrastructure for our metadata. So at the root folder level, let's create a new folder, and I'm going to call it metadata. Okay, now underneath that folder, let's create a new one called images. Okay, so you can download those, there's 3 sample images, and you can put them in this folder. I'm just going to grab mine from my file system here. So I'll copy those into my project. Metadata images. There we go. And you can see they're named 1, 2, and 3. All right, let's go back to our code editor. Now, the next thing we're going to do, and I'm going to close our smart contract for now. And I'll close everything actually. Okay, so what we're going to want to do next is create a new file under metadata. And let's call this CryptoBeetle _1.json. Okay, now you can just have the name correspond to whatever your NFT is called. If you're using my samples, name it like this, or name it in accordance to whatever your own samples that you're using or your own NFT art. Okay, so this is basically going to be a JSON object that describes the NFT. So first we want to have a name. So I'll do, and this is sort of free form. You can, there's no standard to follow or anything like that. So I'm going to say CryptoBeetle 1. Okay. All right, next field is description. And by the way, all of this data, basically it's read in by OpenSea or however you're visualizing your NFTs, and so it can be displayed there alongside of the artwork. I'm just going to keep it simple for this example. Just say CryptoBeetle. Okay. Next, we're going to have image, and this is going to be the URL to the image location on IPFS, which we'll go over in a second, but that's basically your decentralized database peer-to-peer network that's going to host our image and metadata file. So we'll leave that blank for now since we don't have that URL just yet. All right, now we have the attributes section. Attributes, all right, and this will be a nested object. And basically this is just a free-form area where you can sort of describe your image and place any attributes that you want that may, determine the rarity of the NFT or just otherwise describe it. So let's think of, what attributes can we basically have for these images. So if we look at the first one here, maybe we can, if we look at this, let's take two side by side, so we can compare and contrast just a little bit. I won't take too long with this, but so one attribute might be like they have different sort of eyes and antenna sizes, legs and things like that are different sizes, different number of dots. So, and maybe like describe some of the background a little bit. So those are some things that we could use for traits. So first we're describing this guy here. So let's say, also if you're planning on having like multiple NFT collection releases, you can do something like generation, like generation 1, generation 2. That's always a good one to have. So we can say trait underscore type, and we'll say generation. So this is like the category of the trait, and then we'll have the value underneath that. So we'll say value. We'll say this is going to be generation 1. Okay, so that's, oh, whoops, I made a mistake here. So attributes should actually be an array of objects. Sorry about that. So make sure you have square brackets, and then it's going to be a comma separated list of curly braces. There we go. All right. So let's just do a few here. So we can copy and paste some of this code. I'll say trait type, dots, and value, it's going to be 4 for this one. Now let's do a few more, and let's just copy the last one and then modify it to speed things up just a bit. Let's do one for antenna. We call it antenna size or whatever you want to name it. So this one will be regular, the other one will be big. Let's do one more maybe. So let's do one for background. So this will be background type. So we'll just say background. The background for this one is space. Okay. I think that's good for starters, and you can go on and get very detailed if you want, but this will be good enough for our example. All right, so let's just copy this file 2 more times. Okay, and let's rename it. All right, so we'll modify this one for number 2. He'll still be generation 1. The second one, I believe, has 6 dots. And let's change the antenna to large. Background is still space, so save that file. And let's copy it one more time. Paste, and this one will be CryptoBeetle 3. So we'll say 3. We'll change it here. Generation 1 dots. I'm not looking right now, but I think that last one has 4. Antenna is going to be large. Background is actually going to be clouds on this one. And here's another thing. We can add one more attribute because the third one has sunglasses. So note that you don't have to keep this very consistent. In other words, if you have one attribute on one NFT, it doesn't mean you have to have that same attribute on the other ones. It'll just be false or not show up, I think. So it's sort of future-proofs it in that way. So we'll just say, oops, I didn't mean to say yes, true. There we go, we'll make it a Boolean value. All right. So there we are. We've got our metadata in place. We still have to put the image URL, but we'll get to that in a second. Okay, so in order to upload our JSON files and our images to IPFS, we're going to use an application called Pinata, which just makes it super easy. So I'm just going to go back to my browser. I'm going to just Google for this because I forgot the exact URL. Yeah, pinata.cloud. All right, so you're going to need to create a free account. So just click on try for free and sort of go through those motions to set up an account. They'll just collect some information, some basic, email, name, password, things like that, standard stuff. And then once you've done that, we'll go ahead and log in. And I've already got an account, so I'm just going to go ahead and log into my existing account. Okay, so the first thing we're going to want to do is upload our NFT images because we'll need the URL to those images to place into the JSON metadata files. So I'm going to go ahead and click on Upload and navigate to my images folder. Okay, I'm going to choose the first image. Go ahead and click on Upload. Now we'll do the same for the other two. And one more. All right, so we can see that those files have been uploaded successfully, and we can check that by just clicking on the image name here, and that'll open up in a new browser window with our IPFS address right up here. Okay, excellent. So now what we want to do is go back to our code editor and enter in the URL to these images in our metadata JSON file. So what I'm going to do is copy the ID here, switch back over to my editor, and I want to make sure I'm opening my CryptoBeetle _1 JSON file. And in the image property, we'll enter in the URL, https://ipfs.io/ipfs/ and here's where we paste in that ID that we just copied. All right, great. So let's save the file. Let's go ahead and copy this whole URL so we don't have to retype it, and we'll paste it into our other two files, and then we'll just go ahead and replace the IDs there. Okay, so let's grab the ID for number 2. Let's paste paste that here. Okay, let's grab the third one. And let's paste that in our _3 file. All right, great. Make sure those files are all saved. And now we just want to, it's good practice to verify that these URLs are correct. Let's just copy and paste them into the browser window. We'll just wait for that to load. In the meantime, I'll grab the second one. And I'll grab the third one. All right, I don't know why these are taking so long, but let's just wait a minute for those to resolve. There we go. Looks like the first one is good. There's our second one. And there's our third NFT. So looks like everything's been successfully uploaded. All right, now that we've modified our metadata.json files, we want to upload those as well to IPFS. So let's go back over to Pinata, and we're going to click on Upload, File, and this time we're looking for those JSON files. So let's go up one directory, and let's do one at a time here. Let's do the second one. And let's do the last one. All right, great. And we can see that all of our JSON files are uploaded. Let's just do a quick sanity check. Make sure that we've got, yep, there's the JSON that we entered. Let's check the second one. And let's check the last one. Great. All right, so far so good. So our next step is going to be to write our deploy script in order to deploy our smart contract onto the Ethereum testnet. Now, one thing I just want to clarify, it's important to know that nothing about the NFT really lives in the smart contract. It's all the metadata and the image that we just saw uploaded to the IPFS distributed server, distributed database. So basically, our contract, if we pop that open and take another look real quick, when we mint a new NFT, that's taking in a token URI. Now that corresponds to the URL of the JSON metadata files that we uploaded to Pinata, to IPFS, okay? And that in turn points to the NFT image itself. All right, so they reference each other and nothing is actually stored in the smart contract. The role of the smart contract, again, is really mostly to track ownership of NFTs. All right, so with that said, we can go ahead and delete this greeter. This sample smart contract, we don't need that. Okay, I'm going to go ahead and close up the metadata folder. Let's go under scripts, and we've got a script here. Let's just rename this. We're just going to call, we're going to rename this to deploy. Deploy. All right, so let's open that file up. Okay, so the first thing we can do here is clean up some of this sample code and get rid of everything we don't need. So I'm going to start on line 26. I'm going to delete everything above that last main function. Okay, so first we'll need a reference to the ethers library. So I'll say const ethers destructure syntax require hard hat. Okay, now we can start to write out our main deployment logic. So I'm going to create an async function using the async keyword. Function, we'll call this main. Give it some curly braces. Now the first thing we want to do is get an instance, or get a reference to our smart contract. So I'll say const CryptoBeetles, and use whatever name that you're using for your smart contract. And I'm going to say await ethers get contract factory, and again, the name of the contract. Okay, now that we have a JavaScript reference to our smart contract, we can call the .deploy method on it to actually deploy it and get a reference to an instance of that deployed contract. So I'll create that variable right now. I'll say CryptoBeetles with the lowercase c to indicate a reference to the instance. Again, I'll say await CryptoBeetles.deploy. And now here is where I will enter in the name of our NFT collection, which gets passed into the constructor. If you remember, we sort of discussed this a little bit. We reconfigured the constructor to take a string name and symbol at deployment time. So we can now set that. And I'm going to say CryptoBeetles. This will be the CryptoBeetles collection. And for ticker symbol, I'm going to say CBEET, just like that. Okay, great. So next step, we want to write some code just to ensure that our deployment has gone okay. So since this is an async function, I'm going to do a try catch. Okay, so in my try statement, I'm going to say await CryptoBeetles. This is the reference to the instance of our deployed contract. And I can say deployed. Okay. Now underneath this statement, we can write whatever code that we want to run once that we're sure that contract has been deployed. So for now, I'll just do a console log, and let's say contract successfully deployed to, and then I'll reference the address of our deployed contract. So the way we can do that is CryptoBeetles, again, reference to the instance, .address. And that should give us the address to our deployed contract. All right, now let's do some simple error handling in the catchphrase. Console.log, and let's just say here error, and then log an error message. Oops, we need to pass in the error object here, like that. And then we can say error.message. Okay, great. So the next thing we can do is actually mint our first NFT, again, once that contract has been deployed. So let's create a new function for this. We'll say mint NFT. All right, so we got our new function definition. And in here, I want to have another try catch, just like the one we just coded. So let's say const new item ID equals await CryptoBeetles dot mint. Now here's where we'll pass in our the URL to the JSON metadata file for this NFT. Okay, so we'll fill that in just a second, but let's do our error handling first. So I'll say catch error, and we'll just console log. You know, we can just reuse the same error message from here. Well, actually, we'll change it just to make sure we know that this is part of the minting process. We'll say minting error. There we go. All right, now the last thing we need to do is invoke this function from our first try catch, and we'll go right above the console log, and we'll just say mint NFT and call that function. And finally, we'll output one more console log for our minting success scenario. So we'll say console.log, and let's say NFT minted successfully. I can spell successfully, that would be great. Oh, I messed up here too. Too many double letters. Okay. All right, and finally, let's just output the ID for our newly minted NFT. There we go. Go ahead and save that file. All right, I think this looks good. Let's go ahead and do a test run and attempt to deploy our smart contract to the Ethereum testnet, to the Rinkeby test network. And so the way we can do that, we need to use Hardhat to invoke this deploy script. So let's go back to our terminal, or I've got one right here, so we'll just use go ahead and use this one. All right, so you're going to want to make sure that you're in the root directory for your project. So in my case, I need to cd into NFT smart contract. There we go. And one more thing we need to do is actually specify the URL for our first NFT that we're going to mint. Forgot to do that. So let's go back to our CryptoBeetle 1 JSON file, and let's go ahead and copy the URL for the image, and then we'll modify it to actually point to our metadata JSON file. So I'll go ahead and paste this. All right, now all we need to do is replace the CID of the image with that of the JSON file. So come down here to CryptoBeetle 1 JSON, go ahead and copy that CID, and we'll just go ahead and replace it with the one we've got here for the image. And let's just verify that that's correct. Yep, there's our JSON. So go ahead and copy this URL, and let's bring that back into Visual Code, back to our deploy script, and we'll go ahead and paste that into our mint function. There we go. All right, now we're ready to deploy our script, which if it runs successfully, it should go ahead and mint that first NFT. So I'm going to do nxp hardhat run. Now we have to give it the location of our deploy script. So let's say scripts, is it scripts? Yep. Dash deploy.js. And finally, we want to specify the network that we're targeting. So I'll do dash network and then Rinkeby. All right. So as long as we haven't made any errors, with a little bit of luck, hopefully this will work. Oh, I didn't save my file. Close call there. Make sure you save that deploy script. And whenever you're ready to give it a try, go ahead and hit the enter button. Okay, we've got an error, type error, cannot read properties of undefined, reading URL. And that is, where is that coming from? That must be coming from our deploy script, URL. Maybe not actually, I guess that's coming from our, let's see. Let's take a look at our smart contract. Where's that coming from? Config validation. I wonder if that's in our config file. I'm going to pop up open hardhat config. And let's see here. URL. Oh, okay, so it's having a problem reading from our .env file. So let's take a look at that. Ah, here's the error. Rinkeby, spelling error. All right. So yeah, hopefully you guys didn't copy my mistake there, but if you did, just go ahead and correct that, and let's give it another try. I knew it wouldn't work right the first time, so go ahead and try that again. Okay, some more stuff here. Invalid value undefined for hardhat config networks URL.url. Huh. And accounts.url. So what else am I doing wrong in my config file is my next question. Networks URL, process environment, Rinkeby URL. So it doesn't like something about how this config is set up. works. Ah, all right. I don't know how this happened, but I'm missing a property. I need to say Rinkeby and then have a nested object with the config under that. Don't know how I missed that. Sorry about that, guys. Just make that little correction there. I was about to go out to the documentation, but yeah, there we go. All right, go ahead and save that. Oh, I'm missing some curly braces here. A little bit of trial and error to get this right, but okay, I think that looks much better. So yeah, sorry about that, guys. Just go ahead and make that little change if you had the same mistake that I did. And let's try it once again. All right, that's a good sign. I spoke too soon. Compilation failed. Okay, so now we've got a problem with our smart contract somewhere. Uh-oh. Okay. Okay, oh, these are old errors. Okay, so derived contract must override function burn 2 or more base classes define the function with the same name and parameter types. Okay, this isn't something I've run into before. Okay, so basically what it's saying is that we've got some methods from 2 or more classes that are clashing here, specifically between these two, the ERC-721 base class and then the URI storage. So the storage class actually imports this one, and I think we were importing both of them explicitly. That might be the problem. Let's try getting rid of this first import. I don't think we need it. So save that, because this this smart contract actually inherits from the ERC-721. So I think since we're, it's inheriting from it, and then yet we're also importing it explicitly, we don't need to do that. I think that's the cause of these problems here. So, oops. I think we need to remove the reference here because we don't need to explicitly inherit from the 721. So let's save that. Let's try it again, because I don't think we should need to override those methods. So go ahead and hit enter. Let's try the deploy again. Let's see if these contracts compile this time with that small adjustment. Oh, great. Okay, so good news is that the contract's compiled successfully. Bad news is I've got now some sort of syntax error in my deploy script. That should be an easier fix. So let's see. Await is only valid. I forgot an async keyword somewhere. All right, so let's go back to our deploy script. All right, guys, bear with me here. We're almost there. It's this one right here. Okay. So just add an async keyword on that line 15 in front of the parentheses for your mint NFT. I think that's going to do the trick here. Okay. Let's give it another whirl here. Okay, line 17. I guess I must have missed it somewhere else as well. 17, 17, 17. Huh. Okay, I think the problem... Do we need an await here? Is that the problem? Let's try that. If that doesn't work, then I think I'm going to have to make this so it's not nested. In other words, a try-catch inside of a try-catch. There may be some restriction there with async await. Let's try this. I think that's probably what it's telling me. Top-level bodies of modules. Yeah, so this is kind of nested. I think that's what it doesn't like here. Oh, actually, it looks like we got past that point this time. Did we? Let me clear this because it's getting a little messy and I'm now unsure which error messages are from which deployment attempt. So I'm going to run that again. I just want to make sure that we're past any JavaScript and compilation errors. Okay. So let's see what we've got here. Yeah, so it's still not liking that. I'll tell you what, I think we've got a little bit, I need to refactor this code a bit here. We don't need an extra function here. We can just, can't we just put this code right here on line 10? So instead of calling that function, let's just cut and paste our mint function into that try. Well, I guess the only problem there is that we can't get specific minting error messaging. So what's the best way to handle this? Oops. How about if we just do this? How about if we just don't wrap this in a function and we'll just do a try catch down here? Now I'm just thinking, is this going to give us problems with our, the order of operations here? So we're going to try, we're going to await this call, and then I just want to make sure that our contract's deployed before we attempt to mint here. All right, let's just try this for the time being. This is test code anyway, so after we do this, I'm going to show you guys another way to mint contracts. We don't always necessarily want to do it in our deploy script, right? We want to have like one-off mintings. So let's just leave this as it is for now. And let's try it again. I just want to get past these JavaScript errors here. All right, so again, I need to make sure that I'm in the right directory. There we go. Let's try our deployment one more time. Well, I won't say one more time. This is like the 7th or 8th attempt, but I feel like we're almost there. All right. So, insufficient funds. Okay. So the one thing that we need to do is we need to make sure that we have some test ether in our wallet in order to do this. So that's okay. We didn't really lose any time here. We just got past all of our coding errors. So I think what this is telling us is that we're ready to deploy. We just need to get some test ether. So the way we can do that is there's a faucet, which is an application that gives away free ether. And let's do Rinkeby faucet. All right. So here it is, faucet.rinkeby.io. And guys, what we need to do here, it's a little bit awkward, but you can't just directly request the ether. What you have to do is have some sort of social media, like Twitter or Facebook or something. And you have to create a post with your wallet address. Then grab a reference to that post, and that's what needs to be pasted in here. And then we can get our test ether. Okay? So in my case, I've got a Twitter account that's collecting dust, so let's see if I could use that for this purpose. All right, so I'm going to pop open my wallet. And one thing you want to do is open up your networks drop down here, and then we want to select Show Hide Test Networks. Okay, and let's toggle that to on. And I think that's all we have to do. So now if we select that drop down again, there we've got a bunch of Ethereum test networks. We're going to select Rinkeby. Okay, and close this. Now go ahead and grab your account number and go to your social media and just make a post with that account number. That's it. And you can delete this later. So let's see. How do I grab a reference to this post? I think I just click on it. There we go. Is this it right here? All right, let's try that. And let's say give me Ether 18.75. Okay, there we go. Funding request accepted. So for some reason, I'm still not seeing that Ether in my wallet, the 18.75 that we requested. So what I went ahead and did was I sent a couple of Ether from another one of my test accounts just to keep this moving. But hopefully you guys don't run into the same problem. I think maybe the network is just really congested right now. So we've got some Ether to work with. Let's go back and try our deployment again. And we've refactored our code. Just going to tidy this up a bit. Oh, and we need to remove this line 10 since we refactored this function, so we don't need this anymore. All right, and I think we're just going to simplify this script just a bit more because I don't like these two try catches with the awaits here. Let's do without those for the time being. So I'm just going to copy lines 8 and 9, which is our deploy function, and the subsequent console log. So let's just get that outside of our try catch. Let's delete this, and let's just grab our minting functionality and paste that down here. That way we can be sure that one's going to happen before the other. Okay, that's just a little bit cleaner, a little bit simpler. I could probably take some time to refactor this code even more, but it's just an example. And in a real life scenario, I don't think I would really code my deployment or my minting in my deployment script like this. So let's just keep it simple for now. And let's try our deployment again. All right, so I'll go ahead and run that deploy script again. All right, excellent. So it looks like we finally have a successful deployment, and the NFT ID isn't quite printing out how I hoped it would. I think I probably just need to string format that, but that's okay, we don't need that. Let's just grab the contract address, which is this line right here, and let's verify that this exists out there on the Rinkeby network. So go ahead and paste that to your clipboard. Now I'm going to go out to my browser, and I'm just going to search for Etherscan, which is a block explorer, and Rinkeby network. So should be this result right here, rinkeby.etherscan.io. And we can just go ahead and paste that address in here. Hopefully we'll find something. Yep, and there's our contract right here. So I was kind of hoping to see some other information here, such as the NFT collection name. I'm not sure why that's not showing. You typically would see like your token name and tag right here. I definitely see that whenever I deploy to mainnet. I'm not sure why we're not seeing it right here. But that's okay. Let's just go to the next step, which is going to be to go out to OpenSea, which is the NFT marketplace that we want to eventually sell our NFT on. And let's see if we can actually see our NFT through the visualizer. So I'm going to go to OpenSea.io. Okay. And so if it's the first time for you using OpenSea, basically what you do is you don't have to create a traditional account with a login and password. You connect using your wallet. So let's see, I'm going to go ahead and click on the wallet icon here in the upper right and go ahead and choose MetaMask. And it'll ask us to sign the transaction to allow our wallet to connect with OpenSea. So we'll go ahead and approve that, hit next, and go ahead and hit connect. Okay, and it's saying you're viewing data from main network, but your wallet is connected to test network Rinkeby. All right, so please switch to testnets.opensea. So let's go ahead and click on that because we want to make sure that our networks are in sync between OpenSea and our wallet. And I guess we're going to have to connect again, so let's try that. Again, MetaMask. It'll ask us to sign the transaction, approving the connection. So go ahead and click next, connect. Okay, great. So now we're seeing our wallet balance. We're seeing our wallet address right here. Okay. And let's go ahead and click on profile. And this should load the visualizer. Okay, so we got no items to display, which means there seems to be a problem with minting our NFT. So we could actually check and just ensure that this NFT is in our wallet, or see if it's there or not, confirm that at least. So go ahead and copy the address of the smart contract and go ahead and pop open your MetaMask wallet. And so we're only seeing Ether here, but what we need to do is import the token for our CryptoBeetle's contract. So go ahead, click on import tokens at the bottom and go ahead and copy that address there. And you can see that our ticker symbol has auto-populated. That's a good sign. That means it's finding it on the network. Okay, so for total decimal, just do 0 and click on Add Custom Token. Oh, look at that. So it's showing that we have a balance of 1 CBEAT. So it looks like there is an NFT in our wallet. Go ahead and click on Import Tokens. All right, and that way whenever we open our wallet now, we'll see that under our Ethereum balance. Okay, very interesting. So it looks like we do have an NFT. We do have one token. However, for some reason, it's just not showing up in OpenSea in our profile. So I need to do a little bit of side research and see if perhaps OpenSea doesn't support Rinkeby for some reason. Let me do some investigation and get right back. All right, so I've taken a look through all of the project files and I'm not finding anything wrong. So I'm pretty confident in our code at this point because we did successfully deploy our contract and we did successfully mint an NFT, at least to the extent that we can see it in our wallet, right? So at this point, what is our next troubleshooting step here? So we've deployed to the Rinkeby Ethereum test network. We've got an NFT minted in our wallet, but we're not seeing it on OpenSea on our NFT visualizer page. So it seems to me there's either a problem with communication between OpenSea and the Rinkeby test network or some problem with the test network itself. So one thing that I think we could do is find another test network to target and just try to redeploy to another network, another test net, and see if we have any different results. So we can do that pretty easily. Let's give it a try on the Polygon test network, which is called Mumbai. All right, so I'm just going to create a new entry. In fact, we can copy and paste this one. And again, I'm in our hardhat config file under our networks object here. And I'm going to create a new entry for the Mumbai network. Okay. Now we can use our same private key because we'll be using the same account, but we will need a new URL. So we'll call this Mumbai URL, and I'm going to copy and paste this into our env config file. All right, so to get the endpoint for the Mumbai test network, we'll need to go back to Infura. So that was infura.io. And go ahead and log in and go to your dashboard. And you want to go to the project that you created for this. So I'm reusing this project here. I'm just going to click on it. I'm going to go to project settings. And hopefully we can find an entry for Mumbai under our endpoints drop down here. Let's see. Polygon Mumbai. There we go. Core. What is this? Okay, this should be free, so I'm just going to click Update Subscription. Okay, great. So I got a little lost here. So okay, let's go back into our project settings. And I'm just looking for the Mumbai network. There we go. All right, so just go ahead and copy this endpoint here, and we'll bring it back to our project and go ahead and paste that in your .env file. Go ahead and save that. So we can just try to redeploy our contract to Mumbai, and we'll just go hit the up arrow to go back in history a bit, and we'll just change our network target to Mumbai. And hopefully, if I haven't forgotten anything, we can just go ahead and hit enter and deploy this. Let's see if we have any better luck with this network. The good news is there's several Ethereum test networks and a couple of Polygon or one Polygon test network. Insufficient funds. Okay, so we need some testnet for Mumbai. Oh, sorry, I meant test ether or Matic. Oops. Test Matic. There we go. Polygon faucet. And hopefully this is straightforward. Okay, so again, go ahead and let's pop open our wallet and grab our wallet address. This one's more straightforward than Rinkeby. We don't have to go and create a social media post or anything like that. So go ahead and just paste your address in here, hit submit. And then the other thing we'll have to do is enable the Matic network, or sorry, the Mumbai testnet in our wallet. So go ahead and confirm. Request in progress. Okay, so it may take a couple of minutes. All right, so in the meantime, we can go ahead and configure MetaMask for Polygon Mumbai. So the quickest way to do that is to go over to a website called Chainlist, which will just give us a sort of a one-click way to enable different networks in our MetaMask. So let's see, I'm going to search for Mumbai. Here we go, and just click on Connect Wallet. And we'll go ahead and sign this and connect. Okay, and hopefully at this point we should have some Polygon test network options here. Not yet. Oh, add to MetaMask. Okay. So the first step was to connect to MetaMask, then we add it. All right, and let's go ahead and approve that and switch network. Okay, so we are officially on the Mumbai network now. We just double check that. Yep, looks good. So let's head back over and just want to make sure that we have some Matic to work with. Yeah, that's right. We got that. So that test Matic did go through. It's in our account, so we can head back over to the Visual Code and redeploy. So I'm going to clear this out. I'm going to go up, and hit enter. All right, great. So another successful deployment, this time to the Mumbai network. All right, so let's go ahead and go back over to OpenSea and see if with any luck we can now see an NFT in our account. So I'm going to hover over this little avatar and click on Profile. And there we go, one under collected, so that is looking good. And there's our guy. Very good. So CryptoBeetle 1 has been minted, and now it's actually being reflected in OpenSea. So this is exactly what we want to see. Now I can sort of click on this and get some more details here. So we can see the description and here's the name coming from our metadata JSON. We see a sell button here, so we can immediately, if we wanted to, we could click on this and please switch to Rinkeby to sell. So we'll go over that a little bit later. But for now, I just want to see kind of what this looks like here. Description, CryptoBeetle, that's also from our JSON file. Now, if we expand details here, we can see our contract address, token ID. We see that it's an ERC-721 standard and was minted on the Rinkeby blockchain. So the one thing that I'm not seeing here is our traits. If you remember, when we defined our JSON file, we set some attributes here. And I see the mistake right here. This should be an I. But I'll tell you what, for now, let's just kind of continue to explore what we have here. And so we've got all of our information here. We've got some other item activity minted from null address, which just means from the contract address, not from any other particular account, to you 2 hours ago. Okay, so this looks pretty good. Now let's just click on sell and see what this looks like. So switch networks. It's going to want us to switch over to Rinkeby. And let's say go ahead and switch network. Okay, now let's try it again. And so we see that here we can list our item for sale. We can do a fixed price or a timed auction. So it's sort of like eBay. You know, you have an auction option or a fixed price auction option. You know, I tend to recommend that we start fairly low. Well, this is not exactly reflecting actual Ether prices, is it? But anyway, you can sort of play with the numbers and figure out what you want to sell your NFT for, the duration, and there's all kinds of options. You can choose the start date, the end date. Yeah, so this is kind of how you do it. And service fee. So listing is free. Once sold, the following fees will be deducted. Okay, so that's their cut, right? So I'll go ahead and complete the listing, and just so we can see what this looks like. Okay, so it is saying that there's a one-time gas fee for initializing your wallet. And so we just have to do this for the first item that we sell, and any subsequent item, we shouldn't have to pay any gas for listing. All right, so we'll just wait for this to complete. All right, we'll confirm this transaction. Confirming the listing, so we'll go ahead and sign this. And that was our last step. So your item is now listed for sale. So as you can see, the listing process is really the simplest part of all of this. The hardest part is deployment, as you've seen me struggle through it and sort of face multiple issues that we've had to solve. But hopefully that's been helpful to see sort of the vast array of issues that one might run into during a deployment to the blockchain. So hopefully that wasn't too much of a struggle to get through. And so here's our listing. So yay, we've successfully deployed our smart contract. We've minted an NFT. We've now listed that NFT for sale on OpenSea. And here's our listing. Okay, so OpenSea also has a concept of NFT collections. So if we hover again over our avatar and go down to My Collections, we can see that one has been auto-generated for our first NFT. Okay, so we can click on that and get to the collection details. Okay, and it's got all the information. Now we only have one NFT in this collection currently. And so what we can do is edit our collection. We can add a logo image. So let's just grab one of our NFTs for our logo. Featured image. Let's just, again, grab that same image just for now. Banner image. I don't have one at the moment, but you can include a banner. You can modify the name. Let's say I'll call this CryptoBeetle's NFT, just so we could see the change reflected. We've got a custom URL. You can edit this as long as it's valid and unique. You can add a description. Collection of there we go. You can add a category, you can add your social media links, and then royalties. So this part's pretty interesting. So you can collect royalties on future sales of your NFTs. So meaning that if someone were to buy this NFT and then they were to sell it to another party, we could specify that we need to receive a percentage of that sale. And I believe that can be anywhere from 0 to 10%. So I'm going to just go middle of the road here and say 5%. Now they're going to ask for the payout address. So I'll just grab my current wallet address, but this could be any of your other wallet addresses that you want your royalty payments to go to. So we'll just say this one for now. All right, and a couple of different theming options. We're not going to really get too much into that. So I'll submit changes, and hopefully we'll see those changes reflected in our collection. Okay, updated, so let's go my collections. And there we go, so we can see our updates. And so any additional NFT now that we mint from that same smart contract should automatically end up in this collection. Okay, so it's just an easy way to categorize your NFTs. And pretty much you want to have one smart contract per collection if you're using an ERC-721, because it's sort of tightly coupled at the collection name level. Now there's another standard, ERC-1155, which we're not going to cover in this video, but it's a bit more flexible, and it can allow you to actually mint several different collections with one smart contract. But for now, 721 still seems to be the gold standard, so that's what I decided to go with for this tutorial. All right, guys, so far we've made great progress. We've successfully minted our smart contract, deployed our smart contract, minted our first NFT from that smart contract, and now listed it for sale on OpenSea. All right, guys, so in the last segment of this tutorial, we're going to go ahead and mint our final 2 NFTs. So in order to do that, with our first NFT, we basically hooked into our deploy script, and we had some code to deploy our smart contract, and then after that, we called the mint function on that newly deployed contract. So this time, we don't want to rerun our deployment. We just simply want to call into that contract and invoke the mint function. So to do that, we're going to create another script. So let's go ahead and do that now. We'll create a new file under scripts, and we'll call it mint.js. Okay, so in this script, we'll basically only have our minting functionality. Let's go ahead and copy all the code from our deploy script. Control A, copy, and I will go ahead and paste that in here. Now we can, let's just get rid of everything here. Everything in the first main function. Okay, we'll start fresh. All right, so before we continue, there is one mistake that I made earlier that we're going to have to correct, and that was the spelling mistake here under the attributes. So it looks like I've already updated it. All right, so make sure that the I is there. I had left it out before, and that's the reason why we weren't seeing the attributes in the NFT visualizer. So we're going to go ahead and correct that. Just make sure that it's updated in all the files. Okay, good. So we need to go back to Pinata and just delete and then re-upload those JSON files. So I'm going to come over here to More. I'm going to do delete file, and basically I'm going to do the same thing for all 3 of the JSON files. So delete file. And one more, delete file. All right, so I'm going to re-upload these. Okay, luckily this isn't too difficult of a thing to fix here. Okay, great. So I'll tell you what. So we're gonna first finish our minting contract, but before we do that, I want to grab at least the CID for that first CryptoBeetle JSON file, and I want to replace it in our deployment file, because remember we actually minted our first NFT in our deployment file. So what we're going to do is we're going to deploy everything from scratch. We're going to redeploy our smart contract, which mints our first NFT, and then we're going to deploy our CryptoBeetle number 2 and number 3. Okay, because I think we ran into some issues earlier and we deployed the smart contract multiple times, so I just want to make sure that everything is in the same collection, because remember, the smart contract is really what defines the collection as we see it on OpenSea. So We just want to make sure that everything is sort of in agreement. Let's find our mint.js file. And so we're going to need to do a couple of things here. First of all, in our deployment contract, we're basically deploying a contract and then immediately grabbing a reference to it. Okay. This time we need a reference to a contract that's already been deployed on the network. So in other words, we don't have the luxury of sort of saying CryptoBeetle's deploy and then CryptoBeetle's.deployed. We're invoking this script separately, so we don't have a reference to that anymore. So there's something called an ABI, Application Binary Interface, I believe is what it stands for. And what that is, we can find it basically when we compiled our Solidity smart contract. We got a file under, if you go under Artifacts, Contracts, CryptoBeetles.json, our ABI can be found right here on line 5. And if you look at it, all it is it's basically a JSON representation of all of the methods and functions in our smart contract. And so this is sort of the bridge between the Solidity world and the JavaScript world, and it allows us to invoke functions on our smart contract as if it were a JavaScript object in our client-side code. So this is sort of the mapping that we need so that our client-side code knows what's out there on the smart contract on the blockchain. All right, so first of all, let's grab a reference to that ABI. And what we'll do, we'll say CryptoBeetles JSON. And we'll just require that JSON file that we were just looking at. So I'll say require. I need to go up a level and then into artifacts /contracts /CryptoBeetles.sol /CryptoBeetles.json. All right, save the file. Now once we have that, we can reference that ABI directly. So we'll say const ABI equals CryptoBeetles JSON. Oops. .ABI. Okay, great. Now the next step is we need a couple of ingredients in order to connect with our smart contract on the blockchain. We need a provider because we won't be dealing with our wallet since we're invoking the script directly from the command line. So we'll use our Infura provider, and then we'll use that to create a wallet instance, and then we'll connect that wallet using the provider in order to sign any transactions. So we'll need that when we call the mint function on our CryptoBeetles instance. All right, so let's go through this line by line. So the first thing I want to do is const provider. Okay, and I'll say new ethers.providers. And there's a bunch you can choose from, but since we're using Infura, we'll select Infura provider. Now this takes 2 arguments. The first is the network, so we'll say Rinkeby. And the second argument is going to be a project ID. So we can go back to our env file and we can grab the project ID. See, this is the project ID here. We created a variable for the entire URL, but the ethers library actually constructs part of that URL, so we just need the ID here. So I'll say Rinkeby underscore project underscore ID, and we can just grab this from the line above right here. Paste there. Oops, I left off the leading character, so I'll try that again. It's good to catch those mistakes when they happen and not later. All right, and I'm going to save this. I'm going to copy and paste this environment variable into our function as the second argument. Okay, perfect. So the next step, wallet instance, I'll say const wallet. And I'll say new ethers.capital wallet. Now this is going to take 2 arguments. The first one is our private key, which we have in our .env file. So I'll say process.env.private underscore key. Okay. And the next argument is going to be the provider that we set up above. Okay. Next thing we need is a signer, because we need something to sign our transactions with when we call mint NFT. Okay. So I'm going to say signer equals wallet.connect provider. Okay, so that's all the setup that we need. Now we can actually invoke functions directly on our contract instance on the blockchain. So I'll say const CryptoBeetles with a lowercase c, sort of similar how we did it in our deploy script. All right, now I'm going to say new ethers.contract. Okay, now this is going to take 3 arguments. The first is going to be our private key, so we'll grab that in a second. The second is our ABI, which we have, and the third is the signer. Now, the signer argument is optional. If you leave it off, though, the contract instance that you get back is read-only. So we definitely need read-write since we're minting a new NFT. All right, so at this point, since we said that we were going to start fresh and redeploy everything for our final test, we're going to have to actually pause at this moment and deploy our contract so that we can get the deployed contract's address and then enter it in here. All right, so we're all set up here, and we've edited our mint address to reflect that new JSON that we've corrected. So we can go ahead and let's go ahead and find our deploy script. So npx hardhat run script/deploy.js network rinkeby, and let's go ahead and fire that off. Okay, excellent. So successfully deployed. What I'm going to do here is grab our new contract address. I'm going to copy that, and I'm actually going to make this into an environment variable, so I can do contract address equals and paste in the address there. Now I'll just grab this environment variable, save the file, go back to mint, and I can just paste that into our new ethers.contract. All right, great. So now that we've got a reference to our contract on the blockchain, we can use it to invoke the mint function. So I'm going to do CryptoBeetles with lowercase c dot mint. Okay. And now I need the, similar to what we had in the deploy script. So actually I'm just going to copy our mint address from here. I'm going to grab the whole parentheses and save a couple of keystrokes and just paste that in here. Now, of course, I'll need to replace the CID with our CryptoBeetles number 2. By the way, this function should be an await. Make sure you have that. Okay, so I'm going to go ahead and go back to Pinata and grab the CID for CryptoBeetle number 2. That's copied to my clipboard, so I can come back and paste that in here. Now finally, we want to console log some sort of success message. So the console log NFT minted. That'll do for now. Let's save that. And so, okay, that was a lot of typing, but I think we're ready to go ahead and run our second NFT minting. And so what I'm going to do is come back and just modify this script. Let's see, was that scripts dash mint.js dash network rinkeby. All right, let's go ahead and try that. Now while that's going, I'm going to go back to Pinata and I'm going to grab our CID for our third NFT. And I'm going to come back and, oops, it looks like we've got a problem here. Invalid argument. Resolver address is not configured for ENS name. Unsupported network. Oh, I see the problem. You guys probably spotted this, but I've got my env variable in quotes, and that is not correct. Plus, we need to have process.env in order to access our .env file. So All right, let's clear that out and try that again. All right, so I got distracted by that, and I don't remember if I actually pasted in my new. I'm gonna have to grab that again. So much for saving time. So I'm gonna grab my CID for our third NFT. I'm gonna paste it in here. I saw that that second one was successful, so that's great. And let's run it one more time for our third NFT. All right, so if everything goes well here, we'll be able to go to OpenSea, make sure our MetaMask is on the Rinkeby network, and hopefully we should see 3 NFTs. Okay, so I'm gonna go over to OpenSea. I'm gonna just open up MetaMask and make sure I'm on the correct network, which should be Rinkeby. Okay. Now sometimes this does take a while to refresh and reflect, so I'm gonna kind of refresh the page here. I'm gonna go to profile. There's 2 of them. That's great. Okay, let's refresh and see if we can get number 3 in to show up. Still got 2. All right, well, maybe the third one's still coming. Let's check the ones we have and see how they turned out here. Okay, great. So now we're seeing some different properties here. There we go. That's what I was hoping for before. So we've got our antenna trait, our background trait, dots, and the generation. So all this stuff is showing up. This is all coming from our metadata JSON file. Wonderful. And let's go ahead and list this one. So I like the timed auctions. I'm going to stick with that. All right, we'll set a fairly low price here and complete the listing. And of course, we'll have to sign the approval and the confirmation. So this takes a minute just to kind of walk through the motions here. Confirm. And one more time. Great, so let's view the item. And there it is, up for sale on OpenSea. And oh, looks like our third one popped up too, so great. Now notice that, you know, these are all coming from the same collection, and that's thanks to our smart contract that sort of is the organizing factor there. So we can click on this one and set it for sale as well. Well, anyway, I won't do that because I've showed a couple of times. So yeah, so it looks like our final deployment here was successful. We've got all 3 of our beetles. Let's go back to our profile page and see if we see them all together here. Great. Okay. All right, so excellent, very happy. So we've successfully coded an ERC-721 smart contract for NFTs. We've deployed it to the Rinkeby Ethereum test network. We've minted 3 NFTs. We're able to view them all on OpenSea. We're able to list them for sale. They're all within the same collection and organized pretty well. So guys, I think that is all I have for this video. Sorry if parts of it were a little bit rough around the edges, but you know, I think it's important to see sort of the debugging process, and you know, things go wrong all the time in blockchain development, and so hopefully it was helpful just to see, you know, some of the things that you want to check, the troubleshooting process. So thanks for joining, and hope you guys enjoyed it. I'll be coming up with some more videos pretty soon here. So if you enjoyed it, feel free to like and subscribe to the channel. Would love to have you, and really hope to see you in the next video. All right, guys, if you have any questions or comments, please feel free to leave them down below, and I'll try to get back to you guys as soon as possible. All right, guys, thanks a lot. Have a good evening, and see you next time. Bye-bye.